In this video, we will learn the differentiation formulas to find the derivative of the given function. We'll use very basic example to understand the process. Let's begin with the constant rule. What is constant rule? So if c is a constant, then the derivative of the constant function is equal to 0. So this is known as constant rule. Let's try to see some of the examples. In this example, you can see that we have given a 5 as a constant function. So the derivative of this constant function with respect to x by this rule is actually 0. So in the similar way, the derivative of 2/3 with respect to x will be again 0, right? Why? Because 2/3 is a constant function. The derivative of 5 to the power 100. What is 5 to the power 100? 5 to the power 100 is still a constant function, right? So in that case, the derivative of that with respect to x must be 0. The same way, the derivative of pi with respect to x, pi, of course, it is also a real number, right? And so it is constant, so the derivative of that will be 0. The derivative of e, the natural exponential number e, since that is also a constant, so the derivative of that will be also 0. The derivative of sine pi, sine look like a trigonometric identity, but what is sine of pi? Sine of pi is, what is the value of sine pi? 0, right? So that is actually a constant. So sine pi is a constant, so the derivative of sine pi must be also 0. Now let's learn what power rule means. Let's assume we have a power function like this x to the power n, where n can be any real number. Then if we need to find the derivative of such type of power function, then the derivative of x to the power n with respect to x is n times x to the power n minus 1. If you look into this formula, you can see if we have a power function like x to the power n, we bring the power down as a coefficient times, write down the x as it is and subtract the power by 1. So this is the power rule. Let's try to see some example. So we have a power function here given as x square. Our goal is to find the derivative of x square with respect to x. And since this resemble like this power function where in the power we have 2, so we can use the power rule. But how do we apply that? Okay, we have the rule here. We just need to bring 2 down, write down x as it is, subtract the power by 1. So 2 minus 1 will be 1. So 2x is the derivative of x square. Similarly, the derivative of x to the power 1/3 will be, can we use the power rule here? Yes, definitely. Why? Because this is again a power function, because on the power we have some real numbers similar like this, right? So we can definitely use the power rule. So let's apply the power rule, which is bring the power down, which is 1/3, write down x as it is, subtract the power by 1. And in the power we have 1/3 minus 1, so when we simplify that we get 1/3 is the coefficient, x is as it is, 1/3 minus 1 is negative 2/3. So the derivative of x to the power 1/3 is 1/3 x to the power negative 2/3. Let's see one more example. So our goal is to say, if our goal is to find the derivative of x to the power minus 5, then can we use the power rule? Yes, because negative 5 is a real number which is in the power, so we can use the power rule. But how do we apply? We bring the negative 5 down as a coefficient, write down x as it is, and subtract the power, which is here negative 5, by 1. So Negative 5 minus 1, when we simplify we get negative 6. So the derivative of x to the power minus 5 is negative 5 times x to the power minus 6. What is constant multiple rule? The constant multiple rule says that if you have a constant multiply by a function, and if you need to find the derivative of that, then the derivative will be constant multiplied by the derivative of the function. So the derivative of the constant multiple function will be constants times the derivative of the function. Let's try to see some example. So our goal here is to find the derivative of 5 times x square with respect to x. You can clearly see here on this function 5 is a constant and x square is a function. So 5 times x square is actually a constant multiple function, right? So our goal is, if our goal is to find the derivative of that with respect to x, then we can clearly use this constant multiple rule. So if we want to apply this rule, how can we apply this? We need to leave the constant as it is, which is 5, right, times multiply by the derivative of x square with respect to x. And we know that by using the power rule, the derivative of the x square with respect to x is 2x. So 5 times 2x, and if you simplify that we get 10x. So the derivative of 5x square with respect to x is 10x. Similarly, let's try to see the other example where we have 5 over x cube is a function, but if you look at this function can be written as 5 times 1 over x cube. So 5 is again a constant multiplied by 1 over x cube, and 1 over x cube can be rewritten as x to the power minus third. So if you change it into the negative exponent, right? So this is how we can write down. So if we need to find the derivative of 5 over x cube, then by using the constant multiple rule, we'll leave the constant as it is, multiply by the derivative of 1 over x cube, which is x to the power minus third. So derivative of x to the power minus third is, by using again the power rule, that will be bring the power down, which is negative 3, write down x as it is, subtract the power by 1. So negative 3 minus 1 will be negative 4. So if you simplify these, we can write down these as 5 times negative 3 is negative 15 times x to the power minus 4. That's all. This is already the derivative of the function. If you want to rewrite this into the positive exponent, then the answer is negative 15 over x to the power 4, right, if you change the negative exponent into the positive exponent. So this is how we can find the derivative by using the constant multiple rule. So far, we have learned what constant rule means, what power rule means, and what constant multiple rule mean. Now we will talk about what sum rule mean. The derivative of the sum of the functions is the sum of the derivative of the function. So this is called the sum rule. That means if you have two functions, let's say f and z, then the derivative of the sum of these two functions will be the sum of the derivatives of the individual functions. So that means if we have f plus g, and if we are finding the derivative of that function, we first find the derivative of f, we also find the derivative of g, and then just add the derivative together. So this is what known as sum rule of the derivative. Let's try to see some examples. So let's assume that our goal is to find the derivative of this function 3x plus 1. Then you can clearly see here are two functions. Let's say function f is 3x, and let's say function g is 1, and then 3x plus 1 is the sum of these two functions. So if you want to find the derivative of this function, then we can use this sum rule. So let's find the derivative of the 3x, and let's try to find the derivative of 1, right? So find the derivative of 3x, find the derivative of 1, and then whatever comes up, add them together. So derivative of 3x with respect to x will be, by using the constant multiple rule, we can take 3 out, and derivative of x with respect to x is 1, so 1 times 3 will be 3, and derivative of 1, since 1 is a constant, so because of the constant rule, derivative of 1 is 0. So if you simplify, we get this as 3 as a derivative of this function 3x plus 1. Let's try to see another example. Let's say our goal is to find the derivative of 5x squared plus 4x plus 7. Although we have here three functions, but the sum rule can be applied to uh, the sum of the function even more than 2. So on that, in this, you can see the idea here is we just need to find the derivative. It looks like term by term, right? So you can also say this is like term by term differentiation, right? So we can, so let's just differentiate 5x squared, then let's just differentiate 4x, let's differentiate 7. Okay, and so find the derivative of 5x squared, find the derivative of 4x, find the derivative of 7. What is the derivative of 5x squared? By using the constant multiple rule, we can take the constant out, 5 is out, and derivative of x squared with respect to x, by using the power rule, the derivative will be 2x, so 5 times 2 will be 10, so 10x is the derivative of 5x squared. Similarly, what is the derivative of 4x? 4 is a constant, take that out, and derivative of x with respect to x is 1, so 4 times 1 will be 4, right? And then the derivative of 7 is a constant, so derivative of 7 with respect to x will be 0. All right, so all right, that's it, and we just need to simplify, and which is 10x plus 4. So this is the derivative of 5x squared plus 4x plus 7. In the similar way, we can define the difference rule. The derivative of the difference of the functions is the difference of the derivative of the function. So that means, for example, if we have two functions f and g and we have a difference between that, so the function is f minus g, and if our goal is to find the derivative of this difference function, then the derivative of that will be, find the derivative of f, let's say that is f prime, find the derivative of g, let's say that is g prime. So when we find the derivative of f and derivative of g, just find the difference between the derivatives, and that derivative will be, the derivative of the difference of these two functions. So let's see one example. So our goal is to find the derivative of 3x minus 1. So we have two functions here, function f, let's say that is 3x, function z is 1, and we have a new function which is difference between that is 3x minus 1, and our goal is to find the derivative of that. So to find the derivative of this, it's clear that we can use this difference rule. So how do we apply? Let's find the derivative of f, which is 3x. Let's find the derivative of z and just find the difference between that. Okay, so find the derivative of 3x, find the derivative of 1, and whatever comes up, just find the difference between that. So what is the derivative of 3x? By using the constant multiple rule, we can take 3 out, right, and then just find the derivative of x with respect to x, which is 1, so 1 times 3 will be 3, and the derivative of 1 with respect to x, the 1 is a constant, so because of the constant rule, the derivative is 0. So when we simplify, we get 3 as the derivative of 3x minus 1. Let's see one more example. So our goal is to find the derivative of 5x cubed minus 4x squared plus 3x minus 1. By looking at the previous example, you might have realized when we have the difference of the function, we do term by term differentiation. At the same time, earlier we learned what sum rule means. The sum rule also says we can just term by term differentiate. So if we combine those two rules, because here are some difference between some function and then some of the functions, so on that case we can just term by term differentiate. What does that mean? We'll just find the derivative of 5x cubed with respect to x, right? Find the derivative of 4x squared with respect to x. Find the derivative of 3x with respect to x. Find the derivative of 1 with respect to x, and either as summation or difference, whatever sign you have, just carry that on. Okay, so let's find the derivative of 5x cubed with respect to x. So how do we find that? By using the constant multiple rule, which is bring the 5 out and just find the derivative of x cubed with respect to x, and that can be done by using the power rule. And by using the power rule, what is the derivative of x cube? 3x square, right? So 3x square times 5 will be 5 times 3 will be 15. So 15x square is the derivative of 5x cube. In the same way, we can find the derivative of 4x square, which will be 4 times derivative of x square with respect to x by using the power rule. That will be 2x. So 2 times 4 will be 8. So 8x. And since there is minus sign, so carry that on. In the same way, find the derivative of 3x with respect to x, which is just 3, right? So plus 3. And derivative of 1 with respect to x is 0. So just write that down. Done. This is the derivative. Our goal is to just to simplify. So 15x square minus 18x plus 3 is the derivative of 5x cube minus 4x square plus 3x minus 1. By looking at this example, you might have realized that to find the derivative of now actually for any polynomial function, we can do that by using the constant rule, constant multiple rule, power rule, and sum and difference rule of the derivative. We just need to combine these 5 rules and we can find the derivative of any polynomial function.